Thanks for joining us for Watershed Watch in Kentucky's presentation on using a simplified approach to understanding and rating your stream's ability to provide habitat that supports aquatic life. If your habitat rates well but you don't find much living in your stream, there's a pretty good chance that the water quality conditions may be harming in-stream organisms. Or if you found good water quality results from your sampling, but you now find that the habitat values are poor, it may be time to work on a habitat restoration project. For several years, Watershed Watch has used a habitat assessment protocol that was based very closely on that used by the Kentucky Division of Water. It's very rigorous and uses technical terminology that many may not be familiar with. Some samplers commented that the process was too tedious or time-consuming, so it wasn't utilized much by our samplers. In response, this simplified approach was developed to encourage broader use by our samplers. It's based on a protocol used by Maryland's Department of Natural Resources. If more people use this approach, we'll have better data to evaluate conditions throughout the state. It will also expand the number of people that understand and recognize optimal habitat conditions and the underlying complexity of stream systems that serves as a critical component in a healthy overall ecosystem. A habitat assessment will help us understand if conditions are ideal for aquatic life. The verification of their presence through a biological assessment, often of small creatures called macroinvertebrates, can confirm that both habitat and water quality conditions are hospitable. If the habitat characteristics seem to be acceptable, but a healthy mix of aquatic macroinvertebrates is not found, that could indicate that water pollutants are harming their survival. Because many aquatic macroinvertebrates are sensitive to water conditions, and since their populations can change very quickly, they can provide information on the relative water quality in a given part of a river or stream. Some types, like mayfly nymphs, stonefly nymphs, and caddisfly nymphs, are particularly sensitive to impairments, while other types, such as crayfish, aquatic sow-bugs, and flatworms, are less sensitive. The collection and identification of macroinvertebrates in a section of your stream can add to your understanding of its general water quality. Once you are ready to conduct this assessment, you'll either use a paper form that can be printed from the website to record and enter your results later, or enter them directly into the web app using the link that is generated for your site. You'll find explanation on how to do this also on the website under Habitat Assessment Approach. So you'll enter the same basic information at the top of the form as you do for the past chain of custody form. Then you'll check off one or more of the land uses through a visual observation of the surrounding area, your general familiarity with it, or through a Google Maps search if you're feeling extra ambitious. The next portion of the form provides space for you to enter any odor or visual observations of watercolor or materials or substances floating on the water's surface. Guidance for making these observations is provided in the online habitat materials, as well as in this presentation, and through flip cards that can be provided to you. The next section of the form lists the 9 stream corridor characteristics for you to rate from good to poor. Observations for these ratings include the stream itself as well as the land on either side of the stream. After completing each of these observations and ratings, you will total your score and compare it to a habitat scoring chart to determine your stream's overall habitat rating. This slide shows the rating analysis of scores to determine if they are considered poor, marginal, fair, or good. The associated descriptions provide a little more information about what you may have observed and what improvements may need to be made to raise the overall stream rating. Before we delve into each of the 9 stream corridor characteristics, Let's just go over the fact that a habitat is just referring to the natural home or environment of an animal, plant, or other organism. Ideally, we'll find lots of different types of habitat that support many different life forms in a stream and its surroundings. A greater abundance and diversity of life implies a stronger, more resilient overall ecosystem. Again, we'll be considering features both within the stream itself and around the stream. The area adjacent to a stream or river is called the riparian area or riparian buffer. Your assessment form includes ways to note land uses in the area. This is important because land uses can contribute unique pollutants either directly or indirectly as stormwater runs off of the land and picks up contaminants from land used for those purposes. This slide shows the land use categories listed on your form or in the app, each with unique impacts to water. For example, urban areas may contribute petroleum products from vehicles that may leak fluids in parking lots and on roadways. Or fertilizers applied to lawns may create runoff of nutrients such as nitrogen and phosphorus to nearby waterways. Land use for pasture might contribute bacteria and pathogens from livestock manure, as well as nutrients contained in the manure. Cropland may erode and contribute soil and sediment and runoff traveling over land and into the nearest water body. Thus, land use is an important factor in assessing water quality and what measures may need to be taken to improve it. The next section of the form provides the opportunity to note smells that you may detect at the stream site. Your nose is a great tool for information about possible pollution problems. A rotten egg smell may be a sign of raw sewage or decomposing organic matter. If you do find evidence of raw sewage entering the stream, you should report that concern to your city or county engineer for further inspection. A chlorine odor may be coming from an upstream sewage plant discharge, as chlorine is often added to treated sewage before sending it to the receiving water body. It may also be a sign of a swimming pool being emptied or overflowing or an industrial discharge. Sharp, pungent odors may be indicative of chemicals or pesticides in the area or in the water itself. These could be coming from crop or lawn applications or from other sources. A musty odor often accompanies raw or undertreated sewage or manure. Depending on the area, these may be more likely to come from a human or livestock source. Rancid, sour odors may be easily identifiable as dead animals or dumpster sources. A gasoline or petroleum smell may be coming from industrial uses in the area or illegal dumping of waste. And commercial wastewater or wash water, such as from a car wash, may have a sweet, fruity odor. Obviously, you can also look for visual signs of pollution. The color of the water may give you clues to many different pollutants and potential pollutant sources. A brown color, along with floating dirt particles, indicates that soil or sediment is entering the water, possibly through streambank erosion and possibly from land runoff sources, such as construction sites or cropland. Colors ranging from green to yellow to blue can signify algae, sewage, fertilizer runoff, or even cleaning supplies for vehicles. White colors could come from paint, grease, or concrete, as well as swimming pool backwash. Lighter gray colors, along with a musty odor, can indicate gray water from sinks and washing machines or other wastewater sources. Darker gray colors may be caused by raw sewage or other decomposing waste materials. Check for the rotten egg odor in combination with this color. Various colors, including red, black, blue, or purple, could be coming from dyes, paints, and inks, probably from manufacturing sources. And an orangish brown color is likely related to iron in the soil or surrounding bedrock. This color may be coming from land that has been mined. Visual signs of pollution may also be in the form of floating indicators. The top 3 photos show things you might see that result from natural processes, such as the breakdown of organic matter like leaves or twigs, or the growth of bacteria that feeds on elements in the surrounding soil or bedrock, such as iron. The bottom 3 photos are signs of human contributions from household sewer, automobiles, or other oil uses, and from human sewage. Again, these photos and details will be in the flip cards that we'll provide to you. After assessing land uses and visual cues, we will be looking at 9 different stream habitat characteristics and how to rate them from 1 being poor to 4 being good. You can look at these on the back of your habitat assessment form as we go through them. We will start with streambank vegetation. For this assessment, we'll look at the land above the water level and next to the stream on both the left and right banks. We care about streambank vegetation because it provides habitat for amphibians and terrestrial wildlife. It also absorbs floodwaters and the pollutants that they carry, which lessens impacts to the streams and our communities. It's ideal to have a lot, possibly about 90% coverage of this area, with vegetation including trees, understory shrubs, or non-woody plants, and it should be left ungrazed or mowed. So a good rating includes lots of plants, bushes, and trees, and a fair rating is given when there's a mix of these vegetation types covering about half of the streambank area. Streambank vegetation is ranked as marginal when most of the trees and shrubs are gone and mowing or grazing has limited plant growth. And we will rank this characteristic as poor when very little plant life is present along the banks or in the floodplain. Stream channel alteration refers to evidence that the stream has been moved or changed by people. Some evidence of this can include non-natural ways of stabilizing stream banks, such as the placement of large rocks, concrete, or metal mesh baskets of rocks called gabion baskets. Long stretches of straightened stream that was likely adjusted to create more farmland or allow other development, and dams and bridges that can be blocking flow, or dredging or removal of gravel and sand from the stream. We care about this because straightened channels allow for faster water flow, which causes more erosion and damages stream habitat. A good rating for channel alteration is given to streams that have the freedom to bend and curve around the landscape and are not constricted by man-made structures. A fair rating is assigned to streams that have some straightened sections but also some natural bends. You can see that these examples for marginal and poor conditions show very straightened stream channel stretches, concrete bridges, and in the case of the poor example, a channel that is completely covered in concrete with virtually no habitat benefits. Our third criteria is embeddedness. Embeddedness is a technical term for the amount of soil and sediment surrounding rocks on the bottom of the stream. If a stream bed shows a lot of embeddedness, the rocks are almost completely surrounded, as is shown in the graphic for poor conditions on the slide. We prefer to see a mix of gravel, cobble, and boulder particles, so just various sized rocks, that are minimally surrounded by soil and silt. This creates more surface area for macroinvertebrate and fish shelter, spawning, and feeding. The layering of fist size and larger rocks also creates a diversity of niche spaces for aquatic organisms to live and reproduce. This photo shows a good rating for embeddedness, and you can clearly see that the rocks covering almost all of the stream bed have very little silt or sand around them. As the rocks on the stream bottom become more covered with sand and silt, habitat ratings decrease. In this photo, you can see that the rocks are more than halfway covered with silt, giving this stream a marginal rating for embeddedness. If the rocks were completely buried in sediment, the stream would be considered poor for this habitat consideration. Characteristic number 4 assesses erosion of the stream bank. Erosion along the stream can add dirt and sediment to the stream, which harms aquatic habitat. It also lessens the availability of habitat cover along the stream banks. Ideally, we'll see stream banks that are just above the water level of the stream. This ensures that aquatic creatures have access to bank habitat and plenty of water. Once the stream banks become higher than the water level due to erosion, access to habitat decreases. In the photo on the left, noted as good, the stream banks are only slightly above the water level of the stream in comparison to the photo on the right, where the banks are slightly higher than the water level. These two examples show increasing levels of stream bank erosion. You can see that it would be very difficult for fish or aquatic macroinvertebrates to find habitat along these stream banks. The marginal conditions on the left show much of the exposed stream banks significantly above the water level. And the banks on the right are very high and removed from the stream itself. When assessing macroinvertebrate habitat, we also look for available cover on the bottom of the stream. Shelter for macroinvertebrates can include submerged logs or tree limbs, leaf litter, and smaller or various sized rocks that appear to have been in place for a while and unlikely to move. We want to see a variety of habitat niche types at the bottom of the pools, which will include a mixture of gravel and sand substrate materials and lots of aquatic plants and associated root mats. When the stream substrate is all mud and clay, or even all bedrock, scoring for this category is poor. These two examples show streams with few rocks, wood, or leaf litter available for habitat, and are thus ranked marginal to poor. Fish like to seek various habitats for feeding and spawning, including slower, deeper pools of water and undercut stream bank areas where the roots provide shelter for spawning or laying eggs. The photo on this slide shows a stream bank with plenty of undercut bank areas that have tree roots extending over the water. The tree branches will also help keep these areas shaded and cool. The fewer pools, fallen tree limbs, and overhanging banks, the poorer the fish habitat rating. The stream's vegetation buffer, or riparian zone, refers to the plants, shrubs, or trees on the land along and adjacent to a stream or river. The width and density of plant cover in this area tell us about its effectiveness at providing ideal aquatic habitat, as well as absorbing and removing excess stormwater runoff and associated pollutants. Ideally, the buffer width will be greater than 50 feet on each side of the stream and provide a variety of vegetation types, including grasses, shrubs, and trees with little to no mowing or other human impacts. The narrower the width, the less favorable the stream habitat. The photo above gets a good rating. Notice the wide bands of large trees mixed with other plants on both sides of the stream. And you can see that the overhanging tree limbs provide a lot of shade to help keep the stream cool. So how would you rate this stream for buffer width? Well, you need to consider the narrowest buffer. The buffer on the left side of the photo looks like it could be greater than 50 feet up the slope, which is good, but the bank on the right side is only in the 5 to 20 foot range, which is associated with our marginal rating. So you would give this habitat category 2 points for its marginal classification. Category number 8, stream bank stability, is directly related to the previous erosion category, since increased erosion of the bank impacts its steepness or slope and the height of the bank from the water level. Based on the rating descriptions for bank height above water level and slope degree, how would you rate this stream bank? It should receive a marginal rating. The bank slope is just above 45 degrees, and there's a lot of exposed bare dirt that's caving in and falling into the stream. So it's really not very stable at all. For the final characteristic, we are looking at the variety of depth and velocity of the water over a stretch of the stream 30 feet upstream and 30 feet downstream. Again, variety supports a wider range of aquatic organisms. Stream experts have special names for depth and flow types in the stream. A riffle occurs where the stream course drops and the water flows quickly over rocks, producing rough, bubbly water. A run is the fast-flowing water between the shallower riffles and the deeper pools. A pool is probably just what you would imagine, an area of deep, slow-flowing water. And a glide is the area of flow as the water leaves the pool and transitions to a shallower depth. These sequences will help slow the water and release its energy. This lessens the power of the water to erode stream banks, which we have seen can cause other habitat problems. So we have 4 different depth velocity combinations: fast and deep, fast and shallow, and slow and deep. For reference, deep means above the knee for smaller headwater streams and waist high for larger wadable streams. Fast means the water is broken with turbulence because it's moving so quickly. So if you see all 4 of these combinations, your stream should receive a good rating. Only 3 is fair, 2 is marginal, and only 1 is poor. In western Kentucky, where the land surface is typically flatter, it's natural to see fewer of these flow types, and you're especially unlikely to see those associated with faster waters such as riffles and runs. After performing this habitat assessment, you hopefully will have some ideas for ways to improve a stream's habitat. If the buffer areas are sparse, maybe you need to organize an invasive plant clearing followed by a tree and shrub planting. If you find lots of sediment on your stream bed, maybe you need to ensure that local erosion control measures are being used on construction sites and raise awareness about the problem. If the banks are steep and high above the water level, upstream flow volumes from too much runoff may be causing too much bank erosion. Are there stormwater control measures that could be used to help infiltrate some of the runoff and slow in-stream velocities? These ideas could all be part of a community project. There are many insights that can come from performing a habitat assessment of your chosen stream site. If you have questions along the way or after you have your findings, feel free to contact your Watershed Watch Basin's board members for help.